word break. Given a string S and a dictionary of strings, word date. Return true if S can be segmented into a space separated sequence of one or more dictionary words. Note that the same word in dictionary may be used multiple times in the segmentation. So, for example, here we have a uh, S to be that can be segmented into a word dicts words and S is our string, and then in our dictionary of words is word date. And these are two words. So since these words can be segmented into this, we have through here, and in this case also we have apple pen. Apple as our string, and it can be segmented into apple pen through. Note that you're allowed to use dictionary words. So also here it says we have cat. Uh, we have this string cats, cats and dog, and here um, it says false. I think why this is because we're using the same letter here. This S over is being used here, and this D is being made for the dog. If we had the cat and then and then dog, no no, maybe and without the D and dog, then that would be true. But since these are since some of these words are in other words in our word dictionaries, this cannot be segmented into these words. So this is a dynamic programming. Dynamic programming. Let's make our let's make our word date set faster slash one search access. Let's call word set. Let's call it word set, and then let's make set dictionary. Let's put a word date in it. Date. And then let's name this the length of it. Let's name it. Let me go up. Numbers of words of letters. Oops. Letters. Equals to length of S. So name length length of letters, variable name. Let's move down to our, let's make our dynamic. Let's make our dynamic array table to false star term and false values for the corresponding indexes. So let's call it dp equals to, let's make it false, false, and then take that and multiply multiply by our numbers of letters here. Plus 1. Plus 1. So this will make sure that we start from the index of 0. Let's give a dp index of 0, 0, because an empty word is still a 0. An empty word is still hold on, this should be through, sorry. Empty string is a subset. So now let's loop through our loop sum for I in the range of 1 and the length, no, numbers letters. Let me take this, copy this, boom, boom, plus 1, and then for our start pointer, for j in the range of I. So okay, so this is our end pointer. Which is our end pointer. Yeah. So once we for j in the range of, hold on, let me go down now. So if we have dp j and as starting from the end inside our word set and word set, let's take it, let's make dp I to oops, this should be I. dpi will be true. So this means that once we come from here, j, which will be our j, all the way to leet here. So 4, 0, 1, 2, 3. So here will be true, and then So once we start from here, it will be true. That's how we'll be able to know if it's true. So in this case, it will. In this case, um, if we have cats here, boom, and then we come inside here and then find this. Um, hold on, cats with and then sand. Uh, there are overlaps here, so return dp. So this will make sure that if we have all um, we have all the this will index the length that we have. Hold on. Let me return. So this will be a true or false based on the length. Yeah, where's the oh, this is return to. Let's see if it works now. What did I put there? Oops, another one. And it's been able to pass all cases. And that's it for this problem. Let's sum. The time complexity is O of n squared. Space complexity is O of n linear. So time complex of n squared because we have to go to each to I index for hold on. This is our ending, and then we tried every single possible value before moving on to the next one, and so on and so on and so on. And let's submit to see if it's going to pass all cases. And it's been able to pass all cases. And that's it for this problem.